Have you ever gazed up at the sky and wondered what secrets our sun is hiding? We see it every day, but this colossal ball of fire is far more mysterious and bizarre than we can possibly imagine. Recent discoveries, many thanks to advanced telescopes like the James Webb Space Telescope, are rewriting everything we thought we knew. Today, we're diving deep into 7 new facts about our sun that will make you question reality itself. First up, did you know that the sun is humming? That's right, our star isn't silent. It produces a constant, low-frequency hum. Scientists using instruments like the Solar and Heliospheric Observatory, SOHO, have detected these sound waves rippling through the sun's interior. This isn't sound you could hear in space, of course, as space is a vacuum. Instead, these are pressure waves, similar to seismic waves on Earth. They are created by the constant churning of hot plasma and gases in the sun's convection zone, the outer layer just below the visible surface. By studying these waves, a field known as helioseismology, scientists can map out the sun's internal structure, temperature, and composition, much like how geologists use earthquakes to understand Earth's core. It's like giving our star an ultrasound, and the music it makes tells us about its health and inner workings. Next, let's talk about solar tsunamis. Yes, you heard that correctly. Our sun experiences massive tsunamis, but they aren't made of water. These are gigantic waves of hot plasma and magnetism that race across the sun's surface. These events, officially called Moraton waves, are triggered by solar flares' immense explosions of energy from the sun's surface. A single flare can release the energy of millions of hydrogen bombs, and this blast sends a shockwave rippling outwards. These plasma tsunamis can travel at incredible speeds, reaching over 1 million kilometers per hour, and can be hundreds of thousands of kilometers high. Observing these tsunamis helps scientists predict when bursts of solar radiation might head towards Earth, giving us a better chance to protect our satellites and power grids. The third fact is a real head-scratcher. The sun's atmosphere is hotter than its surface. This is known as the coronal heating problem, and it has baffled scientists for decades. The visible surface of the sun, the photosphere, has a temperature of about 5,500 degrees Celsius. But as you move away from the surface into the sun's outer atmosphere, the corona, the temperature skyrockets to over 1 million degrees Celsius. This completely defies the laws of thermodynamics. It's like walking away from a bonfire and feeling it get hotter instead of colder. Several theories are trying to explain this mystery. One leading idea involves something called nanoflares. These are millions of tiny, continuous explosions in the corona, much smaller than the giant solar flares we see. While individually weak, the combined energy of these constant nanoflares could be enough to heat the corona to its extreme temperatures. The Parker Solar Probe is currently flying through the corona, gathering data that might finally solve this puzzle. Fact number 4 is about the sun's bizarre weather. We have rain on Earth, but the sun has coronal rain. This isn't water, but massive clumps of superheated plasma, each the size of a large country, raining down from the corona back onto the sun's surface. This process starts when dense pockets of plasma in the corona cool down rapidly, from millions of degrees to just a few thousand. This cooling causes the plasma to condense and fall, pulled by the sun's immense gravity. These fiery showers fall along magnetic field lines, creating spectacular glowing loops called coronal loops. Scientists study this coronal rain to better understand the sun's magnetic field and the constant cycle of matter and energy between its surface and atmosphere. It's a cosmic recycling system on a mind-blowing scale. Now for a truly mind-bending fact. The sunlight that warms your skin today started its journey from the sun's core thousands of years ago. The energy from the sun is produced deep in its core through nuclear fusion, where hydrogen atoms are fused into helium. This process releases photons, which are particles of light. However, the sun's core is incredibly dense. A newly created photon doesn't just fly straight out. Instead, it gets absorbed and re-emitted by countless atoms in a chaotic random walk. This journey, called the random walk of a photon, can take anywhere from 10,000 to 170,000 years to travel from the core to the surface. Once it finally breaks free from the surface, it takes only 8 minutes and 20 seconds to travel across 150 million kilometers of space to reach Earth. So, the light we see today is an ancient relic from the sun's distant past. The sixth fact is about the sun's powerful magnetic field, which is not as simple as we once thought. It has a complex, tangled structure that flips its polarity approximately every 11 years. This is what drives the solar cycle. During a period of solar minimum, the sun's magnetic field is relatively calm and orderly, like the magnet on your fridge. But as it approaches solar maximum, the field becomes incredibly tangled and chaotic. This twisting and tangling is caused by the sun's differential rotation. It spins faster at its equator than at its poles. This churning motion creates sunspots, solar flares, and coronal mass ejections. Then, at the peak of the solar maximum, the entire magnetic field dramatically flips. The North Pole becomes the South Pole, and vice versa. Then the cycle begins all over again. Finally, our last fact sounds like something straight out of science fiction. The sun could have a long-lost twin. Many stars in the universe are born in pairs or multiples, in what are called binary or multi-star systems. Our sun, however, appears to be single. But a recent theory, proposed by physicists at Harvard University, suggests the sun did have a binary companion when it was born, about 4.5 billion years ago. This hypothetical star, nicknamed Nemesis, would have been a similar mass to the sun. The theory suggests this companion star was eventually pushed away by the gravitational pull of other stars in our sun's birth cluster and now wanders the Milky Way as a rogue star. The existence of Nemesis could help explain some long-standing mysteries of our solar system, such as the strange, distant orbit of the dwarf planet Sedna and the composition of the Oort cloud. While we haven't found Nemesis yet, the search continues. From its mysterious hum and plasma tsunamis to its superhot atmosphere and a potential lost twin, our sun is a place of endless wonder and shocking surprises. It's a constant reminder that the universe is far stranger and more fascinating than we ever dared to dream. The more we learn, the more we realize how little we truly know. What other secrets is our star hiding in plain sight? If you enjoyed this journey into the bizarre truths of our sun, make sure to like, subscribe, and hit the notification bell for more mind-blowing content from your favorite channel, Space Repo.